Okay guys, I'm back with part 2. So let's finish up this review packet by turning to page 3. We have this chemical equation up here for photosynthesis. We have carbon dioxide plus water produces glucose plus oxygen. The question is, how can you tell if any equation is balanced? Well, you can determine if an equation is balanced by identifying the number of atoms of each element on both sides. If there are the same number of atoms for each element, then the equation is considered balanced. It is following the law of conservation of mass, which says that matter can't be created or destroyed. So however much we start with is how much we need to end with. That's why in a chemical equation, you can look at it and you see the same elements. I see carbon on the reactant side, and I see carbon on the product side. And I see oxygen on the reactant side and oxygen on the product side. And I see hydrogen on the reactant side, and I see hydrogen on the product side. So I have the same elements from before the reaction took place and after the reaction took place. So the only difference is that over here, the one carbon atom was combined with 2 oxygen atoms to form carbon dioxide, and 2 hydrogen atoms were bonded with an oxygen atom to form water. And I had 6 carbon dioxide molecules and I had 6 water molecules. And then these bonds between the hydrogen and the oxygen, between the carbon and the oxygen, these bonds broke, and all of these atoms rearranged to form brand new substances. And I see that over here. I still have carbon, hydrogen, and oxygen, but I no longer have carbon dioxide and water. Now I have new substances formed. The glucose is something different. I didn't start with glucose. And the oxygen is different. I didn't start with oxygen. I started with carbon dioxide and water. So I ended with the 6 carbon atoms bonded with 12 hydrogen atoms bonded with 6 oxygen atoms to form this compound glucose. And then I had 6 O2 molecules floating around. So this is a chemical equation, guys. It uses chemical symbols and subscripts and coefficients to represent a chemical change. And we have the same elements on both sides because the law of conservation of mass says I have to. And then to tell if the equation is balanced or unbalanced, we have to know the number of atoms of each element. So I did a little ERP chart up here so that we could determine if the equation in fact was balanced. So we only have 3 elements in this equation, like we've been saying: carbon, oxygen, and hydrogen. The coefficient here tells me that there are 6 carbons on the reactant side. I take the 6 times the 6 times the 2 oxygens to get 12 oxygens, plus the 6 oxygens over here in this compound for a total of 18 atoms of oxygen on the reactant side. And then the coefficient 6 times the 2 hydrogens gives me 12 hydrogens on the reactant side. On the product side, I have 6 carbon atoms and I have 12 hydrogen atoms. And then I take this 6 atoms in this compound and add it to the 12 oxygen atoms over here, and I get 18. So this is in fact a balanced equation because I have the same number of atoms of every element on both sides. Which substance represented in the equation is classified as an element? Well, carbon dioxide is a compound because it is 2 or more elements bonded together. Water is also a compound. It's 2 or more elements combined together. Glucose is a compound. It's 3 elements combined together. But this one here, this is just a single type of atom. There's only oxygen atoms in this little chemical formula right here. So this represents the element, and oxygen is the element in this equation, this little chemical formula right here, the 6O2. Moving down to the next section, chemical equations, products and reactants. We have the same formula that we saw on our Wix. The calcium carbonate produces calcium oxide plus carbon dioxide. How many elements are in the reactants? Elements: calcium, carbon, oxygen. There are 3 elements in the reactants. How many atoms are in the reactants? So I do my little training wheels. I've got 1 calcium, I've got 1 carbon, I've got 3 oxygen for a total of 5 atoms on the reactant side. Does the chemical equation represent a chemical or physical change? Well, even though I start and end with the same elements, they've rearranged to form new substances. So this is a chemical change. How many elements are on the product side? Well, if I started with 3 elements, the law of conservation of mass said I should end with 3 elements. I have calcium, oxygen, carbon, and then of course oxygen again. So there are only 3 elements: calcium, oxygen, and carbon. How many atoms are in the products? Well, there's 1 calcium in this compound, 1 oxygen in this compound, and then there's 1 carbon in this compound and 2 oxygen in this compound. So 2 plus 1 plus 1 plus 1 is 5 atoms on the product side. So you can see that this is also a balanced equation. How many grams of CO2 were produced? Well, if I started with 142 grams of calcium carbonate on my reactant side, I have to end up with a total of 142 grams on my product side. If 106 grams are from the calcium oxide, then the remaining amount will be the amount of carbon dioxide. So I take 142, I subtract 106, and I end up with 36 grams of carbon dioxide produced. A 2 kilogram rock is dropped into a graduated cylinder filled with water. The water level rises from 2 milliliters to 10 milliliters. What is the density of the rock? Well, density equals mass divided by volume. The mass of the rock is 2 grams, it tells me right here. And the volume of the rock, well, I have 2 different volumes here. I have the 2 milliliters and the 10 milliliters. So which one do I use? Well, I use both. This is the original level of the water, and this is the final level of the water after the rock was dropped in. So I take the final volume, 10 milliliters, I subtract 2 milliliters, and I end up with a volume of 8 milliliters for my rock. So 2 grams divided by 8 milliliters is 0.25 grams per milliliter. Using the word bank to complete the explanation of the model below, well, here we have a model in an aquarium. We have some blue ice, and you can see it's coming down, it's going across. We have a heater over here with some red food coloring that's just getting squirted into the water, and then the water is going up and coming back over this way. So here's the word bank. We're going to be using the word higher and the word sink twice. So A, the cold water released from the cup has a higher density and will sink in the aquarium. So here's the water. It's got a greater or higher density, so it's going to sink in the aquarium. As the colder water moves across and gains thermal energy, the water will become less dense and rise up in the aquarium. That's statement B. Statement C, the warmer water will begin to lose thermal energy as it nears the cup of ice. This now cooler water will have a higher density and will begin to sink in the aquarium. And so this cycle of convection continues with the cooler fluid sinking and the warmer fluid rising as a result of the greater density and lower density. And so we've got the transfer of heat within the aquarium through the process of convection. And now to our weather map. How many different types of fronts are shown on the map, and name them? Well, here's a front right here with alternating warm, cold, and they're on different sides of the boundary line. So this symbol represents a stationary front. Here's another frontal boundary right here with the triangles. That represents a cold front. And then the third frontal boundary is right here. The circle, circle, circle represents the warm front. Find the warm front near New York. That's this one right here. What direction is the front moving, and how do you know? Well, the front's going to move in the direction that the symbols are pointing. So this front is moving to the northwest. What weather is Montreal most likely experiencing, and what weather map symbol did you use to determine this? Well, Montreal is right about here. The warm front is approaching Montreal, but it has not passed through yet. And warm fronts bring persistent clouds and rain, that move in ahead of the front. So the temperatures in front of the warm front are cooler than behind. So the weather conditions in Montreal are cooler now than they will be after the front passes, and rainy because of all the rain that is associated with this very slow moving warm front. And then locate the stationary front. What direction is the front moving and how do you know? It's not really supposed to be a trick question. It's just supposed to be easy. Stationary fronts are stationary, so they don't move. They may shift just a little bit one way or the other, but they don't have any overall forward or backward progress, as the cold air mass is pushing one way and the warm air mass is pushing the opposite way. Stationary fronts will stay put until another weather system comes and moves them out of the way, or the temperature between the two air masses reaches an equilibrium and then the front just dissipates or disappears. So guys, that's the end of your review packet. Hopefully you've had an opportunity to make corrections. If you're still having questions about any of the concepts on this review packet, please do not hesitate to go to tutorials this afternoon. No, I won't be there, but you can go see Mr. Burris or Miss Timmons or Miss Parente. Just take your review packet in there, put a little star around the questions that you do not understand, and they will help you with those questions so that you can be ready for your final tomorrow, which is Thursday. So come in tomorrow ready. You'll need a pencil, and I will provide your test. I will provide your Scantron, but you need a pencil and you need to be ready to go. So study hard, and I will hopefully see you tomorrow.